Greetings, class, and welcome to your lecture on database table relationships and then table relationships and operations within ArcGIS. So how do these rules that adhere to databases in general play out with our software within ArcGIS? So the first thing we should probably do is come to a common understanding of what a table is. Tables are exactly what you think they are. They consist of fields and records, which are also known as columns and rows. In GIS, we use tables to store attribute information, so information about our features. These tables can be retained within your GIS data, so the tables that are within a shapefile or the tables that are within a geodatabase feature class, or they can also be standalone tables, so just single tables that are not tied to a GIS dataset, but they have information that could be used by a GIS dataset. So data within the tables can be queried to answer questions, whether those tables are within a GIS dataset or they're just standalone. And then the way we take advantage of standalone tables within GIS is to link them to our GIS data. And the terminology for that is joining them. And we'll talk about the different types of joins that are available throughout the lecture here today. When it comes to standalone tables within ArcGIS, the format, if you're building a table on your own to store information, or if you're getting a table from someone else that has information that you know could be joined to your GIS data, the best way to do that is in Excel format. So that can be in .xls or .xlsx, either format works, but just understand that each of the worksheets within your Excel document, that's the table that's going to be available. You cannot add an entire Excel document to your ArcPro or your ArcMap project. You add the individual worksheets. So if you're building a worksheet, sometimes it's nice to name those worksheets, no spaces or special characters, but name those worksheets something that makes sense to you so that when you see them in the file viewer and catalog in ArcPro or ArcMap, you can discern which of the worksheets within the document that you wanted. You will also see another type of table format we've talked about before in the data types lecture. That's a DBase4 table, and that's the one that has that .dbf extension. We've already talked about what DBase was, that it was the equivalent of Excel at the time shapefiles were developed. That is the file type that shapefiles are built off of, and those types of files work great as standalone tables in GIS. The difference now is that Microsoft removed the capability to save out DBF files from Excel about 4 or 5 years ago. So we really don't have a good way to create DBF files, so that's why most of them that we create now are in Excel format. But you can open up a DBF table in Excel, but you cannot edit it and then save it. If you've edited it, you need to save it out as an Excel document. All right, so let's get into these table relationships that we're going to talk about. And these are just table relationships in any type of database. So this right now could just be a database class where we talk about one-to-one table relationships, one-to-many, many-to-one, and then many-to-many relationships. What shifts it over to GIS, and specifically for ArcGIS, is we're going to talk about how these relationships, not only how they function across database tables, but how they function in the software and which tools in the software support which types of joins. And you'll also notice in the software that it mentions words such as destination and source, and we're going to talk about these scenarios in terms of the Esri ArcGIS terminology of source and destination as well, to kind of help you when you get to working with the tables in the software. So we're going to start off with the most simple database relationship that you could have, which is the one-to-one relationship. And this is where one and only one record in a table is related to one and only one record in another table. So our example here is that we have a list of homeowners' street addresses and a list of addresses in a parcel database. So we know that in the United States, the convention is only one address should ever be associated with one parcel. So if we're looking at it in the address database, we know that we would be connected to only one parcel ID number. And if we were looking at the parcel database, we know that that parcel is associated with one and only one address address in the address database. So you can see down there that we have table 1 and table 2. If we were to combine these two in the way that it's set up right here now, the ArcGIS destination, that is the table where things are moving to. All right, that's the destination. And the source is where it's coming from. So think of this as flowing. It's flowing from the source to the destination. So the way we have this set up here is that the parcel IDs could be joined to the table addresses if there was a common key item in these two databases. If you were to flip table 1 and table 2 and make the parcels the destination and the addresses the source, then the addresses would come and be joined to the parcel data. So that's the one-to-one relationship where you have only one record in each of your data sets or each of your tables that could be related to one another. The next one we're going to talk about is a little bit more complicated. This is the one-to-many relationship. This is where one record in a table may be related to many records in another table. And on this one, the direction of destination and source tells you whether or not you are a one-to-many or a many-to-one relationship, which is the next relationship we'll talk about. This direction that we have going here, having table 1 being our counties and table 2 being a list of cities. If we wanted to join our cities to our counties, so going from the source to the destination, notice how you have one county and many cities. Well, our county database only has one table record for each county, but our cities, there's multiple cities in each of these counties. If we were to do a traditional table join with these two databases, we would lose data from our source table. And how does it decide which data you lose? Well, it's whatever's listed second. So in this particular example, if we were to do a table join, Boone County would get only the city of Zionsville, Butler would get only the city of Trenton, and Latah would get the city of Moscow. And what would happen is that Boone and Butler counties would lose data associated with them. So in this way, this is something that is not supported by a traditional table join. It doesn't mean that the software won't let you do it. The software will let you do it, but you as the human, as the good data steward, need to know that if you have two data sets that have this relationship, you have the potential to lose some information along the way. We'll talk about later on with table relates how we can take advantage of this relationship, keep these two data sets separate, but create a virtual connection between them so you could see what was related to one another. But if we're just talking about joins right now, this would not be supported within a table join. However, the flip of this relationship, the many-to-one relationship, where many records in a table may be related to one record in another table, this would be supported by a traditional table join because we have a record in our destination where everything in our source could come in and find a home. So in this example, we flipped this so that our destination table is our cities and our source is our counties. So if we wanted to connect these two and do a table join, we could connect Boone County up to both Zionsville and Lebanon, Butler to both Trenton and Middletown, and Latah to Moscow. So we're not losing anything out of our source data set. So this is a relationship, that many-to-one relationship, where nothing is lost, so it is supported with a traditional table join. Our final relationship that we're going to talk about is the many-to-many relationship. And this is where many records in a table may be related to many records in another table. A lot of times what you get is almost a spider web looking effect if you were to track the connections between these two database tables. So in our example here, we have our table 1 to be a database of students, and table 2 to be a database of parents. Now, knowing what we know with how kids and parents work, we know that each student could have multiple parents and each parent could have multiple students. So that many relationship goes both ways. So here for Lisa, she has two parents, a Mr. and a Mrs. Stint, and Kyle Stint has those same parents. So Mrs. Stint has two kids and Mr. Stint has 2 kids. So you can see how these relationships get a little bit more complicated. If you were to try to do a traditional table join from table 2 to table 1, what's going to happen here is that each student can only hold one parent. So for each student, they could potentially lose one parent in the record. And if you were to flip it here and move the parents to table 1 and the kids to table 2, each parent, if they have multiple kids, could potentially lose a child in that table relationship. So this is another scenario where the relationship is not supported by a traditional table join because you could lose information from the source while moving to the destination. This is another example of a relationship that is supported with a table relate, which we'll talk about here in a couple of slides. But first we're going to talk about how these table relationships are used within ArcGIS specifically for a table join. So a table join is what connects one table to another by the one-to-one or many-to-one relationship. It is dependent upon a common item, sometimes referred to as a key item. So if you've taken a database class, this should be very familiar, usually, especially with the term key item. So there has to be something similar in both those tables that indicates which fields should connect up to each other. And the thing to remember about these table joins in any ArcGIS software, whether it be ArcMap, ArcPro, or ArcGIS Online, is that a table join is only a virtual connection between your tables. The original tables are not altered. It is only a virtual connection within that ArcMap project, within that ArcPro project, or within that ArcGIS Online instance or map that you're working on. In your exercise, in your activity, we will go through a couple of different methods for retaining the joined information. If you really wanted to keep it there or pass it on to someone else, there are a couple of different procedures you can do, but just understand that if you just do the table join, it lives there in your ArcPro or ArcMap project. But if you were to pass that data set on to someone else, it would still just be the original data without the join. All right, table relates. These are very similar to table joins in that they follow the same rules. You have to have a common item in both of the tables that connects them. But instead of moving your source to your destination and making that physical connection across the table, the two tables now are going to remain separate, and there's just going to be a virtual connection between the two of them. This allows us to take advantage of those more complicated table relationships, like those many-to-many table relationships, because we don't have to worry about losing source information as we move towards the destination. We have the ability to maybe click on our destination table here and see that building type 103 is associated with multiple records in this other table, and we've selected 2 of them. So it's a way to keep them separate and yet still be able to see the connection between the 2 database tables. So there are some rules that you have to adhere to for table joining and also table relating. Both tables have to have a common item, which again is what we call that key item. The item has to have the same set of information inside of it, or the joins just don't make sense, that it won't find anything to join across. So there has to be a common item, and it has to have the same types of information. Now, it makes logical sense to have that common item or that key item have the same name, but it's not necessary. The names can be wildly different or just slightly different. Often they're not wildly different because that doesn't make a whole lot of sense. But you'll see through our activity example that we're going to run across these 2 fields called OCAP code, which is just that there's a code for some data that's called OCAP. And then in one table it's going to be OCAP code, no underscore. In another table it's going to be OCAP code with an underscore. And that's fine. So if the names are slightly different, that's not what's driving the connection. What's driving the connection is that there's something common inside and that the fields that you're trying to join have to be the same type. So string fields can only be joined to string fields, and number fields can only be joined to numbers. And while that makes logical sense, the thing to keep in mind is that in a lot of databases, you can have numbers, but they're actually stored as strings. A very common example of this is the US Census data, where our census blocks and tracts and block groups all look like numbers. But in the census data, those values are stored as text. So you have to be careful sometimes on how you're joining your tables, and you have to make sure you can understand what the actual item type is before you go to try to join data. So one question you might be asking is, well, how do I know what the field type is? In ArcPro, you have to get to this from catalog. In the catalog tree, you would right-click on your data file or your standalone table, go to design, and then open up the fields view. And I have a screenshot for you here in just a second that's going to show you exactly what that looks like, because we're going to go through an example. So let's look at the example between 2 tables in ArcPro. We have a standalone table here at the top, and then we have a feature class table down here at the bottom. All right. So let's see where we opened these. So in catalog, I right-clicked on my standalone table name, went to design, and then saw that there was a fields option, and I open up that fields option. In fields is where I get to see all of the fields in a top-down view, and then I get to see any of their aliases. I get to see their data types, their links, any other properties associated with those fields. So I can see here that my OCAP code field is a data type of long. We're going to go over all the different data types here in a couple of slides, but if you don't recognize that long is a type of number. It's a number that has up to 14 spaces in there where you can put in a digit. So it's the long. It can hold the largest numbers within your within the software. All right, so now let's go and look at the data set, the feature class table. And we opened up its data properties, its field properties, and we can see that we have a field called OCAP code with no underscore, but its data type is also long. So let's evaluate both of these tables to see if they have what it takes to potentially be joined by that OCAP code, making the assumption that there's information in those two tables under that field that are similar. Well, do both of our tables have a common item? Keeping in mind it doesn't have to be spelled exactly the same. And do both of our fields, are they the same type? And indeed, yes, they both do have a common item. And yes, that common item is the same field type. They are both longs. So we know we could set up a table join to connect up these two tables. Now here's where we're going to have a brief pause on table joins and just talk about field data types. So over the course of different data structures over time, with each different data model comes different terminology for field types. So I'm just going to real quick walk through this and just know that this slide is here for all of your references moving forward if you have any questions about what a particular field type means in a particular data model. So you will still sometimes see in documentation the field types that came out of the coverage data model. So characters were a character field type was the same as a string or a text where you would type letters. A binary was a number type, and binary, remember, is just zeros and ones. Integer was a whole number, and it could be any size. There wasn't any difference between a shorter value and a longer value. Numerics were the values that could hold numbers, but they could also hold decimals. All right, so you could hold decimals, and also floats and numerics there could hold the decimals. And then the date, there was not an applicable, you could put in date, but there's not an applicable length to the date field in coverages. All right, let's move over to shapefiles, which you're probably more familiar with, and talk about how they compare with the geodatabase data model. So in a shapefile, if you have text, it's going to be called string when you look at it in the software, text in a geodatabase model. In the shapefile data model, we only had numbers and floats, so whole numbers and then numbers that could have decimals. There were not individual field types that dictated how many characters or how many spaces could be filled up in that field. In the geodatabase model, they blew that out so that you would have different field types and different field names for different numbers of characters that could be held within a numeric field. So you have short integers, which are often just called shorts, and that is data that's 1 to 4 with no decimals. You have longs, or long integer, which was up to 9 in the number of fields you could carry, and with no decimals. Then you also had doubles here, where you could have 10 to 19 characters, up to 19 characters with no decimals, but you could also have decimals in the double. So in the float and in the double model here within geodatabase, if you see float or double, that floating precision and double precision is what those are short for. You can have decimals in that. You don't have to, but decimals can exist. Whereas if you have shorts and longs or numbers, you cannot have any decimals in those. And then down here, you can see that you also have specific date fields for the shapefile. So when we were looking at those fields before that were indicated as long, it just means that they could be up to 9 characters and they're not going to have any decimals. All right, so this is just for reference to help you understand what the length of each of your fields could be and what they translated to maybe in other data models when it came to how you talked about the type of field that you have. All right, so we're going to end here on just a real brief conversation about relating tables, which we talked about a couple of slides ago. So it does define a relationship between the two tables. It follows the same rules as joins about the common item, and it also allows you to take advantage of those one-to-many and many-to-many relationships. So what it would allow us to do here in this example would be we could select on one county and highlight multiple cities, just like in that past example where we saw where there was one record in a table highlighted, and through the relate it was able to select for the multiple records associated with it. The interface for creating a relate is very similar to the interface for creating a table join. We might get into a table relate exercise later on in the semester, time dependent, but if you ever have any questions about how a table relate plays out and what a scenario would be where you might need one, just let me know and I can give you some examples. All right, so next what we're going to do is you're going to move on to your spatial and table join activity. That's going to start you off by doing a spatial join and then having you do some basic table joins to give some value added to a data set that you've been given that you then need to provide back out to a client, but they need to have some additional information attached to the information that they gave you, and you're going to see how you can go about that. So get on to that activity and make sure you ask any questions that you might have along the way.